Hello, and welcome to a new lesson, new science lesson. And today we will be talking about surface water and ground water. So, this was the topic of today's lesson. Type, what are we going to be talking about exactly? We have a few topics. This can serve as your checklist when you're going on with this video. Whenever you understand a certain point perfectly, just write a check on it to keep track of your progress. Okay, so we are going to talk about a few topics. The first thing is, where on earth is fresh water found? Where can you find fresh water on earth? Is it only on the surface? Then we are going to talk about surface water, an introduction to surface water, then an introduction to groundwater. Then we will be talking about each one of them specifically and with more details. We are going to be talking about surface water. We will know about things called channel, gradient, river flow, stream load, and watershed. These are all related to surface water. Then we will talk about groundwater in aspect 2, aquifer. We are going to know what an aquifer means, water table, recharge, discharge, and so on. So these are the topics we will be talking about today. The first thing is, where on earth can you find fresh water? As we said, only 3% of Earth's water is fresh water. And most of this 3% is actually frozen as ice and snow. So only about 1% of Earth's water is fresh, liquid, available water. Only 1%. This 1% of fresh liquid water is found both on and below Earth's surface. So you can find some on the surface of Earth, like rivers, channels, streams, and so on. These are kind of small rivers. We will be talking about them shortly. And you can find water below Earth's surface, like we talked about last lesson. Water on Earth's surface is called surface water. So fresh water on Earth's surface is called surface water. Water below the Earth's surface, below the ground, is called groundwater. So we have two forms, two types of water: surface water on the surface, groundwater under the ground. And this tiny percentage of Earth's water must meet the large demand that all living things have for fresh, clean water. This is why it's very important to keep track of our usage of water, to limit our usage of water, to not waste water as much as we can, because as we learned, they are very scarce. So now we will have an introduction to surface water. Water on the surface. Surface water, groundwater. Surface water, groundwater. Surface water may begin as precipitation in the form of rain, snow, sleet, or hail on Earth's surface. It flows from higher ground to lower ground with gravity. The water that flows across the Earth's surface like this is called runoff. And the runoff that is flowing over the ground sometimes enter large bodies of water like oceans and seas and is poured in it. Introduction to groundwater. So we talked a little bit, just an introduction to surface water. Now we will have a little bit of an introduction to groundwater. Some rainwater and water from streams, as we can see, seeps down into the ground, collecting in spaces between the rock particles under the ground. Type, can anyone tell me what was the name of this process? Pause the video, try to have a guess. Yes, it is called infiltration, as we said last lesson. Okay. The water table is the upper boundary of the rock or sediment that is saturated with water. يعني فين الwater table هنا في الimage دي؟ The water table is the upper limit of the part of the ground that has water. هنا water اهو، water water، واخر limit للwater is this dotted line. So this is the water table. Now we will be talking about surface water with details. How does water move on Earth's surface? Water trickling down a hillside may flow together to form a stream, eroding soil and rock to make a channel. So the water that drops from precipitation will be collected together and they will form a stream. When this stream erodes soil and rock, takes a little bit of soil and rock, it is called a channel. A channel is the path that a stream follows. This path, for example, the water is the stream and the path is the channel. Over time, the channel will get wider and deeper as the stream erodes more rock and soil. For example, this channel was narrower than this, but it kept eating soil and rock from the sides, and so it got bigger and bigger. Next, we talk about something called a tributary. A tributary is a smaller stream that feeds into a river. So for example, this is the river. This right here is the river. As you can see, it's pouring in a body of water, in a big body of water, like a sea or an ocean or whatever. طب فين tributary? This is a tributary. Why? Because it feeds into a larger river. طيب what is a river system? It's a group of tributaries, streams, and the main river, like all of this thing. So this is a river system. This is a tributary. This is a tributary, tributary, tributary. This is the main river. A river system is a network of streams and rivers that drains an area of its runoff. Water flows downhill, meaning from an upper surface to a lower surface, just as we see here. This part is 145 meters high. This part is 125 meters high. So when water drops here, it will flow downhill in this direction. Of course, the steeper the land is, the higher this gradient is. Yani gradient is a measure of the slope of the land. So the steeper, the higher slope this land has, the higher gradient will be, the more and faster water will flow. River flow is the amount of water that moves in a given amount of time, the speed of the water flowing. And of course, it will increase as the gradient increases. The steeper this gets, the faster the water will flow, and the higher the river flow will be. Finally, we said that water will take a little bit of soil and rock from the sides into itself, will erode, will eat some of it. The rock and soil and sediment and all materials carried by a stream are called stream load. So, to revise quickly, we have a stream, which is a small amount of water moving on land. A channel is the path that the stream is taking. A tributary is a stream that feeds into a river system. A river system is a network of streams and rivers that drains an area of its runoff. Gradient is how steep the ground is, and this affects reverse flow, which is the speed by which the water is flowing, and the stream load is the materials like soil, like rock, like sediment, and stuff that the stream is taking as it goes. Finally, we have something called a watershed. A watershed is the area of land that water flows across before draining into lakes or oceans. So a watershed is actually the land that has the water, the land that has a river or a stream or a tributary. It is the area of land that water flows across before draining into lakes or oceans. Streams, rivers, floodplains, lakes, ponds, wetlands, and groundwater all contribute to water of a watershed. To understand this more, there will be a video attached on Google Classroom. Watch it as you hear this explanation once again, and you will understand watershed perfectly, inshallah. So this was about surface water. What about groundwater? We said that when water trickles down and seeps from the surface and reach a rock layer with no pores or cracks, the water pools to form an aquifer. What is an aquifer? An aquifer is a rock layer that stores groundwater and allows the flow of groundwater. This is the ground. This is the surface of Earth. This is all under the ground. The part under the ground that has groundwater is called an aquifer. Okay? So water drops on the surface of the Earth. It seeps down by infiltration and gets collected in an aquifer. An aquifer stores water in open spaces or pores like these. هنا عندي rock بس في شوية spaces, and these spaces are where the water is collected under the ground. The storage space in an aquifer is measured by porosity, which is the percentage of the pore space in rock. For example, this aquifer right here, we will call it porous. This aquifer has high porosity. Why? Because there are a lot of spaces between the rocks where water can be stored. So, the greater the pore space, the greater the space available for water to be stored, the higher the porosity is. What about permeability? So, groundwater is assessed by porosity and permeability. What is permeability? It is a measure of how easily water can flow. For example, can water flow from this area to this area? No. So now I have low permeability. طيب, can water flow from this area to this area? Yes. طب from this area to this area? Yes. From this area to this area? Yes. It's all connected together. So هنا I have high permeability. So porosity is a measure of the space, the size of the space itself. لكن هنا is a measure of how connected the pores are to one another. I use في الأكوافر بقى هيبقى عنده high porosity يعني space كبيرة to store water and high permeability so that the water can flow freely. طيب هنا عندنا زي quick exercise. Here we have a bunch of rocks connected together with no space whatsoever for water to be stored. فبالتالي هيبقى عندي low porosity and low permeability. طب هنا it says that you have many small pore spaces. So you have pore spaces اهي, the white ones, but they are isolated from each other. They cannot, the water cannot flow from here to here, or from here to here, or from here to here. So you will have high porosity because there is space for water to be stored, but they're not connected together, so low permeability. طب here, you have a lot of space. جميل، يبقى high porosity. And the water can flow from one space to another. يبقى high permeability too. Perfect. طيب what about here? The brown is the brown are the pores. So these brown dots are the pores between the rock and the soil. طيب. The space is limited. It's not a lot. And they are absolutely not connected to one another خالص. So low porosity, low space, low permeability, low connection. Okay. Finally, we talk about recharge and discharge. What is recharge and what is discharge? The process by which surface water trickles down and enters an aquifer is called recharge. يعني the aquifer is getting recharged. It is increasing its amount of water in it. And the area in which this happens is called the recharge zone. So the recharge is when surface water turns into groundwater. يعني surface water من هنا trickles down and enters an aquifer and increases, recharges the water in it. طيب, what is discharge? It is the opposite. The process by which groundwater under the ground becomes surface water. How? This happens when the groundwater pours down into an ocean or into a sea or into a river or whatsoever. Okay? So recharge is surface water turning into groundwater. Discharge is the opposite. Groundwater becoming surface water. Through discharge and recharge, the same water circulates, converts, and moves between being surface water and groundwater. As we can see, they are two opposing processes. Recharge, surface يبقى ground. Discharge, ground يبقى surface. So there is a way for them to circulate between each other. Thank you. I hope you understood. We will be discussing this inshallah in the coming lectures if you have any questions.